Okay, so last time we looked at the lazy functor, which was a monoidal functor. Here it is, lazy. And what it does is simply take any contract C and turn it into a contract that expects nothing. We always have to have an output type, but in JavaScript we can supply nothing to a function. So this expects nothing on the input and C on the output. We found that this was a monad. There's the functor part. Here's the unit, which simply takes a value and wraps it up in a function that returns that value. And then the flattened part says if I have something wrapped in two of these, then I just invoke the outer one and I'll be left with one that has a single one of those at the end. So there's a monad. And it's monoidal because if I have a lazy product, I can invoke that lazy product and get a real product and then map this lazy lifting over the top of it and get a product of lazy things. So because I have this way of going from a lazy product to a product of lazies, it's monoidal. So now, what's this good for? Well, let's try and do a recursive data type. Now we have arrays, but suppose for a minute we didn't. Then we might want to write a list type, for instance. So we could try, and we know that a list of x's, here I'm using Scala notation, is either the end of the list, so we'll use none, or a pair consisting of a data type, a value that passes the contract x there, or another list. So here we've got pairs. So this would be prod n, and this would be maybe monad. Let's try and implement this in JavaScript. So we say list is a function. It takes in a contract. I'll use C instead of X here. And then we want to return coprod s. So if it's the end of the list, the only thing we can accept is this one value. This is effectively nil in Haskell or none in Scala. And then otherwise it's a pair consisting of something passing the contract we gave it. And then the rest of them should match list of C. Now immediately this should set off alarm bells because if I try and say list of int32, well, in order to construct this contract, I need to construct this contract, and in order to do that one, I have to construct list of int32 again. So this will recurse indefinitely and then blow up with the stack overflow. This doesn't work. So we need to think of some way to delay applying this. And the right way to do it, I've got right here. So as before, a list of something that passes contract C is either none, and this single value for the end of the list marker, or it's a pair here, so I've got prod n again, a pair with C and this thing. So here, instead of immediately constructing list C, I wait until I have the tail, and then I check the tail is of type list C. So that will, once I give it a list, it'll check the first element, passes C, and then check that the second element passes tail. So this list is going to be big and ugly. It'll be something of the form, well, out here we've got coprod S, so it'll have to start with sum. And then the second thing will be a list where this thing passes C. Say we're doing int32s. So 1. And then the second one has to pass list C. So if we were encoding the array 1, 2, 3, we get 1 and then sum 2, sum 3, none, end of list. So it's a lot more verbose, but you can see how it has this linked list structure that you recognize from your data structures classes or whatever. The array is more of a random access thing, whereas this is a real linked list. Right, so now what if we want a stream? In Haskell, these two are, this list data type is also the data type of a stream, because in Haskell everything is lazy. In JavaScript, if you tried to provide this thing with a stream, it would eagerly call this on the tail every time and would expand the stream all the way out, and you wouldn't have any chance to compute things without blowing out your stack. So to get a lazy recursive type, we add in this laziness right there. So now I can construct a finite stream with, I'll just do the equivalent of that, keep it short. There's a lazy string. Right here, this wraps up none in a thunk, in a closure, a function that when you invoke it, it will return this value. So what do we get here? It's either none or sum. Here we see sum. Something that passes C. Well, this is int32, so that passes C. And a function of the tail. Well, it passes this K block thing here in his tail, then says return lazy stream C of tail. Well, lazy is just the same thing as HOM, expects one argument. So this says, I expect tail to be a function, and I'll wrap it up in, I'll guard it with another function that says, once you eventually invoke this thing, you better get a stream C out. So here, when I eventually invoke K of this thing, I should get a stream C out. Well, that one matches that part, so we'll get stream C out. And pull up the console here. That's in a debugger. Run. Now I can say S equals stream int 32. Good. And then a particular stream instance equals stream, S of some Okay, so it passed the S contract. Now if we pull out STM1, we get the head of the list followed by the guarded tail of the list. So STM1 gives us the tail of the list, and then we invoke it. And that also passed this part here, the stream C contract again. Okay? So what if I had done something else here? If I had said K of blah. Well, we'd expect this thing to check that it's a coproduct with either none or some. Yes, that's some. And then the second part will be a product, where the first one passes C, yep. And the second one gets wrapped up in a guard. So this will get wrapped up, but we won't be able to check it immediately. So there it worked, but if I try and invoke STM11, there it says, hey, blah is not a valid stream. And so we've got this lazy checking of the tail going on. On the other hand, if I had said L equals list of int 32, there we go, and then said L of some so the head of the list is 1. The tail of the list has to be a stream. If I had put in something else, say blah, I'm sorry, the tail of the list has to be a list. If I'd done that, it immediately says blah should be an array instance. Well, let's give it an array instance. Hey, I expected a string. At this point, it's already expanding it and looking for the tag in the coproduct. So you have to put in a coproduct here. If you said, tag. It says, I expected a 2-element array for my coproduct. right? It's got to have a tag and a value. So blah 0. I don't know what the blah tag is, right? So got to turn it to, say we want the end of the list. None. Oh, 0 is not an array instance. So this list guard is eagerly expanding the list and checking every piece of it all the way down. Whereas the stream guard or contract waits until you invoke the tail to check the tail.